In 1982, interacting with a personal computer required immense physical dedication. On a machine like the Timex Sinclair 1000, you only had 16 kilobytes of memory to work with. You weren't even typing in the modern sense. You were physically pressing little chiclets on a flat membrane keyboard, translating basic code line by slow line. The storage system was a standard audio cassette tape. It took up to 5 minutes of absolute focus just to load a tiny program, and the process routinely failed on the second or third try. Back then, when a user spent all winter typing commands and received nothing back but a blinking cursor on a fuzzy television screen, they didn't doubt the quality of their code. That isolation was simply the baseline physical reality of an unconnected world. Fast forward 43 years, and that same user carries a supercomputer in their pocket. Theoretically, they are connected to billions of other minds instantly. Yet, when a seasoned professional posts a nuanced observation to a public network today, the response they get is exactly the same: a lonely, blinking cursor. It hasn't always been this way. Between 2008 and 2012, digital platforms operated on the logic of the social graph. The system was entirely human-centric. If you declared an intention to follow a specific colleague or an insightful theorist, the platform delivered their output directly to you. A complex framework posted online would reliably generate immediate, multi-layered debates among peers across the globe. Today, when a professional experiences zero engagement on a thoughtful post, the natural reflex is to internalize it. They assume their ideas are stale or that they've lost touch. But analyzing the environment as a thermodynamic system reveals that this silence is a byproduct of the digital architecture itself. The technology that fostered open, professional connection has evaporated. To understand why modern ideas are met with a deafening silence, we have to examine the specific mechanical changes that engineered the global town square out of existence. Around 2016, major social platforms observed a new competitor pulling in staggering retention metrics without relying on pre-existing relationships. That catalyst was TikTok. Realizing they were leaving vast amounts of attention on the table, platforms abandoned the relationship-based social graph and adopted the interest graph, an algorithm optimized strictly for keeping user eyes on the screen for as long as possible. This chart contrasts the processing energy required for two distinct types of digital content. On the left, a 500-word paragraph on systems theory represents a high-friction path. The user must stop scrolling, read dense text, and synthesize the argument. On the right, a 15-second, highly visual video designed to trigger an instant emotional hit requires exactly zero cognitive load. When you pause to think deeply about a high-friction post, the interest graph algorithm flags that hesitation. A pause is a moment you might minimize the application. Because the system is rewarded exclusively for reducing friction to zero, it actively filters out content that requires serious thought. The needs of a thinker seeking nuance are mathematically opposed to the survival requirements of the modern algorithmic platform. In science fiction author Lou Sixon's universe, interstellar survival operates on a brutal premise. Resources are finite, and any civilization you encounter must be assumed hostile. In this dark forest theory, broadcasting your location invites an immediate preemptive strike. Silence is the only logical survival strategy. Looking at this diagram, you see a specialized idea shared safely among a small, trusted group of peers. Context collapse occurs when that idea is ripped out of its intended frame and fed directly into a hostile, universal audience that lacks any shared domain knowledge. All the nuance, challenging premises, and inside assumptions are immediately stripped away. A provocative intellectual question posed to peers becomes decontextualized evidence for outrage. Once the mass audience weaponizes that content, the resulting damage to a career or reputation can be devastating. Intelligent discourse has not vanished from the web. But serious thinkers have recognized that broadcasting a high-friction thought onto a public feed is tactical suicide. The survival instinct dictates a retreat. Current estimates suggest over half of all web traffic is now driven by bots. When a human sits down to write a careful analysis, they are competing against massive automated systems generating synthetic engagement, perfectly optimized to game the algorithmic feed. In the mid-20th century, sociologist John B. Calhoun created an experiment known as Universe 25. He provided a population of mice with perfect temperature control, unlimited food, and unlimited water. But as the population grew, the sheer density of the environment caused all complex social structures to break down. Calhoun called this the behavioral sink. Even with total abundance, the constant, overwhelming social pressure turned toxic. The mice stopped maintaining their nests, ceased normal rituals, and withdrew into a stressed, catatonic state. We see an identical psychological consequence in the human digital experience. Users sense the sheer volume of synthetic rage bait in the comment sections. When a professional realizes that dedicating cognitive energy to debate an automated language model is entirely futile, they radically disengage. When the energy required to defend a point exceeds the potential for a human response, the logical choice is to stop. This silence on the feeds is a form of sensory self-preservation, a tactical withdrawal from an environment where the human signal has been drowned out by noise. If the visible public feeds are fully enclosed by noise, algorithms, and behavioral sinks, human intellectual progress should be dissolving into chaos. Yet complex scientific research continues. Culture continues to evolve. We can map this digital paradox to modern astrophysics. When physicists observe the visible matter of a galaxy, the stars and the gas, they find that galaxies spin far too fast for their visible mass to hold them together. Mathematically, without another force, the outer stars should be immediately flung out into the void, disintegrating the entire structure. This diagram maps the invisible mass known as dark matter. While undetectable to telescopes, it provides the gravitational scaffolding required to keep cosmic structures intact. The modern internet mirrors this architecture. While algorithms manage the visible spectrum, professional intelligence has migrated into cloaked survival channels. This intelligence hasn't vanished. It has simply adopted a non-interacting survival mechanism. The coherent core is still out there, providing the gravity that holds professional fields together, even if it no longer registers on the public radar. Intelligence now flourishes in dark social. These are the encrypted group chats, invite-only Discord channels, and private professional newsletters. They're highly structured environments designed specifically to provide context safety and keep algorithmic predators out. The youngest demographics already treat this as their baseline reality. Sociologist Sherry Turkle identified this adaptation when she noted that modern students are frequently alone together, physically present in a space but entirely isolated by their devices. By locking into their screens and sealing out the physical world with headphones, they are deploying a physical Faraday cage. This is a pragmatic way to manage attention, filtering out local entropy to maintain a connection to their private digital networks. For the professional trying to navigate this landscape, the strategy is clear. You must execute a tactical retreat from the public feeds and practice radical self-curation. That means prioritizing intellectual inputs that build friction directly into their distribution, like charging a fee to physically filter out the noise and guarantee a high baseline of shared intent. The algorithm manages the visibility of the public square, but it exercises absolutely zero control over the curiosity of the dark matter. The most valuable, coherent signals are still broadcasting out there. You just have to build a new, quieter receiver.